Hey, what's going on, everybody? So, Mr. Flores here, and this is a video that's dealing with the Pythagorean Theorem, okay? Which, again, is a nice little theorem that was developed by the ancient Greeks by a man called Pythagoras. Now, if he really developed the theorem by himself, who really knows? Some people say his wife did it. Some people say his school full of little worker bees did it. But regardless, it's named after him, and it's called the Pythagorean Theorem. Okay. The Pythagorean Theorem is something that helps us with right triangles. Okay, so basically we're going to find out and look at how the Pythagorean Theorem was created, and then I'm going to do some problems with it, and we'll call it a day. Okay, so let's say I have three squares here: a blue square with a side length of 3, orange square, side length of 4, teal square, side length of 5. Okay, and we put them together like this, it forms a right triangle, where our right angle is in the bottom left here. Okay, meaning this is 90 degrees, okay, making it right. Okay, so I know it's not perfect, but hey, we'll let it be. So what we want to do is we want to find the area of each square. Okay, so the area of the blue, the area of the orange, and then the area of the teal. Okay, again, we remember to find the area of something, you take length times the width. Since the length of this side is 3, and the square, it's all 3. So 3 times 3 gives us 9. Okay, the area of the orange square, again, both of these sides are 4 since it's a square, gives us 16. The area of both these are 5. 5 by 5 gives us 25. Okay, so this is 9. This is 14. Nope, this is 16. And this is 25. Okay, so basically, we notice that there's a special type of relationship with the two smaller squares and the area of the largest square. Okay, so if we take the area of a small square, add it to the area of the other small square, the sum of their areas is equal to the area of the large square. Okay, so that is the Pythagorean theorem. Okay, it says that if you have a side A, square it, plus a side B, square it, it's equal to the largest side, C, squared. Okay, so if we're looking at a triangle, oops, I'll draw that a little better. Okay, so if we're looking at a triangle, and this is our right angle side, it says that if you take one leg, square it, take the other leg, square it, it's equal to the hypotenuse squared. Okay, so this right here is the hypotenuse. It's the side diagonal that's wrong. Hypotenuse. Okay. Again, it's the side that's directly across from our right angle. Okay. In a right triangle, it's always the longest side. The other two sides are called legs. Okay. So basically, it's the leg squared plus the other leg squared is equal to the hypotenuse squared. Okay. And as long as this stays true, it is a right triangle. You'll never find a right triangle that disproves this. Okay, it's never ever going to be false. It's always going to be true. All right, so this is the whole idea. This is how the Pythagorean theorem was developed. Okay, and this is the very basic theorem where this is a leg, this is a leg, this is the hypotenuse. Okay, so let's say we have a triangle that has a leg of, so let's say we have a leg equal to, alright, so here, I know the video just cut out real quick, I forgot the problem I was going to do, but let's say that we have a triangle, okay, that has a leg of 5 inches, another leg of 12 inches, we need to find the hypotenuse. Okay, well, if we go back to our theorem, we know that if we square both the legs and add them, it's equal to our hypotenuse squared. So all you have to do is take each leg, substitute it into your equation, and solve for C. So we're going to go along and we have, oh, that's too light. We're going to have 5 squared, since it's one of our legs, plus the other leg squared, and that's going to be equal to C squared, aka the side of our hypotenuse. That's what we want to find, so that's what we have to solve for. Well, when we put these together, we know that 5 squared becomes 25. 12 squared becomes 144 is equal to c squared. 25 plus 144 becomes 169 is equal to c squared. All right. So now if we remember from algebra, if we have c squared, the way you undo something being squared is you take the square root of both sides, okay, and then you simplify. The square root of 169 is 13. C squared just becomes c, and the length of our hypotenuse is 13 inches, because we know that c is 13 inches, therefore the hypotenuse is 13 inches. Okay, that's really all the Pythagorean theorem is. You take your legs, square them, add them together, solve for c. Okay. Another way we can do it is the other type of problem, which is the same idea, it's just a little different variation. Okay, so let's say that we know one leg is equal to let's say one leg is equal to 8 inches. The hypotenuse is equal to is equal to 17 inches. Now we need to just find the missing leg. Okay, but again, you just substitute everything into your equation. Well, the one leg is 8, so we know it's going to be 8 squared. Plus, we don't know the other leg, so we're just going to put b squared for now. We're going to set that equal to the hypotenuse squared, which is 17. Okay, again, once you get your equation, it's really just simplifying algebra, or simplifying this equation and solving for b. So you know 8 squared is going to give us 64. We don't know what b squared is, but 17 squared is 289. Okay, so again, we just need to solve this algebraically. Okay, we want now this b squared to be all by itself. So in order to get the b squared alone, we subtract 64 from both sides, and you get b squared is equal to 225. All right. So we know b squared is equal to 225. Again, the way you get rid of a square is you take the square root of both sides. Okay. B squared becomes b. The square root of 225 is 15. And your final answer is 15 inches. So we know the missing leg is 15 inches. All right. So really those are the only variations of the problem. You can be given 2 legs, you find the hypotenuse. You can be given a leg and a hypotenuse, you find the missing leg. But it really boils down to just substituting values into an equation. Okay. Now it can get more difficult because you can get like, I'm going to do another problem where you can get like tricky types of answers. Okay. But we're going to spend more time with this. But again, this is just the nutshell. This is the basics of the Pythagorean theorem. Okay. So let's go on and we're going to do a little word problem. So here's the Pythagorean theorem. I'll just put it up there. Okay, let's say we have a building, okay? We have a building here. All right, I don't know what kind of building it is. It's just a red building, all right? And let's say we're trying to get to a window right here, all right? We don't know how long our ladder has to be, but we do know that our ladder, okay, is going to be 10 feet from the building. There's a coding issue, and we can't be any closer than 10 feet from the bottom of our ladder. All right. We also know that the window on the building is going to be 15 feet high. Okay. We need to find out how long will our ladder be. All right. Well, this is just an easy application of the Pythagorean theorem because if we look, we know that our one leg is 10 feet. The other leg is 15 feet. So the thing we're trying to find out is the hypotenuse. How long is that? Okay, and another way you know that you're trying to find the hypotenuse is because obviously if the building is built straight up and down, the 90-degree angle is where the building meets the ground. Therefore, the side across from that is our hypotenuse. Okay, so to find out how long our ladder must be, you just take 10 squared plus 15 squared, set it equal to c squared, because it's a leg squared plus leg squared equals hypotenuse squared. Now when we simplify, we get 100 plus 225 equals c squared. So 100 plus 225 gives us 325. equals c squared. Okay, again, to get c alone, use square root both sides. And you're going to get that c equals 18.03 feet. Okay, so our ladder must be 18.03 feet long. Okay, so again, that's just an application of the Pythagorean theorem. You find out what your legs are, find the hypotenuse, and you just solve it for your variable c. All right. So I'll do one more problem where I give you the leg, I give the hypotenuse, and we must find the other leg. Okay. So let's just say our one leg is going to be 6 inches. Our hypotenuse is going to be 12 inches. We got to find the missing leg. So we know that it is leg squared plus other leg squared equals hypotenuse squared. Okay, so 6 squared becomes 36. We don't know what b squared is. That's what we're trying to find. We know that 12 squared is 144. We want to get this b squared all by itself, so you subtract 36, and you get b squared equals 108. Square root both sides to get the b squared to become a b. And you know that the square root of 108 is going to be b equals 10.39 inches. Okay? And again, that's it. That's all she wrote. So if you really think about it, there's two variations of problems where we're trying to find the Pythagorean theorem. You can be given a leg and a hypotenuse, and you must solve for a missing leg. Or, like our ladder problem, you're given both legs, and you must find the hypotenuse. Neither of them is very hard once you decide and figure out what you're given, okay? Because you're literally just substituting the values into the equation, simplifying and solving for a variable, okay? The only thing that most kids forget is that when you're trying to figure out what is c squared, you take the square root of both sides, all right? And again, you just plug that into a calculator. Like here, b squared was equal to 108, took the square root of both sides, and b just becomes 10.39, okay? The other big thing is make sure you label if you're given measurements. But hopefully this video taught you the Pythagorean theorem. Again, it's very, very useful in mathematics, and it's very, very simple, as long as you understand the basics of what each part of the equation means. So hopefully you learned a little bit about math from this video. If you have any questions, email me, let me know, and have a good one.